So as it says, today you have the take-home due. I think when I looked earlier, a bunch of you had already put it up on Blackboard, so you're all set. And it just needs to be there. I think I put it, just has to be by the end of the day, so midnight. If you do have problems uploading it, you can email it to me instead. So either or. I'll end class a little bit early today. If there are any, see if there are any really last minute questions. And then the next thing we have is the test. So since people are still joining, wait a minute. So the test will be next week. Not too many people actually responded. So either Monday, Wednesday, or Thursday, people responded. There were 5 people have tests on Monday. So the test will not be on Monday. And there was 1 person that test on Thursday. But I think what I was going to try, and you'll let me know if this works, is have the test Thursday, which actually most people did, but give the option to also take it on Friday. And so what I would do is have you just, if you didn't want to take it on Thursday, you'd email me telling me what time on Friday worked. So does anyone have a problem with either of those days, either Thursday or Friday? Easily write down. So test. Right. So if you want to take it on Friday, you'll send me. So I'll put out a post sometime later this week explaining this so you have it. But yes, you will. Also, in terms of this, if you are taking it at a different time, so you're in a different time zone, so our usual class time at 4:30 doesn't work, then you'll also send me an email. And what I do is I'll set up different groups, and the different groups will have the test available to them at different times. And because of that, there'll probably be at least a few different versions. So at this point, I haven't decided exactly how far we're going to get, so I'm not sure what exactly is on the test. It will start with it'll start with what was after on test 1. So from wherever we finish there, which I forget, to however far we get, say, probably Monday, because then Wednesday, of course, we won't do anything new. Also, because the test is this late, there probably will not be another quiz, which means we'll have the 3 quiz grades and the 2 tests. So any questions about this setup of what's coming up? Okay, so today we'll continue with what we started last week, which is we'll do stocks. So do 1 or 2 more examples of just the basic background thing to get the terms down. Then get into Brownian motion by itself. Basically, so yeah, so in theory we have a class Monday, the Monday after that Thursday, but obviously we don't have a final, so yeah, so that's pretty much it. So what I would probably do is just have you come in and ask questions about, I don't know if I'll have the test by then, but if I have the test graded by then, you come and ask questions about that or stuff like that. So leave it kind of a bit vague. Yeah, I'm deciding. So I'm in the next couple weeks, deciding exactly how I'm going to work. But what I've done for other classes for quizzes is on Blackboard under assignments, I can upload a PDF and make it available over a certain amount of time. and then you can upload the answers. And you just need to upload by the time that's given. So it's probably what I'm going to do because that's the most basic one. And in which case you have kind of three options. One, if you have a printer, you can print it out, write on it, and scan or take a picture of it and upload it. If you have, like I do, a tablet, you can just download the PDF, write on the PDF with your tablet, upload the file, or you can just write on a regular piece of paper, write up the answers again, either scan or take a picture and upload it. And what I'm probably going to do is, so the test itself hopefully will be made to be a bit under an hour, so a little bit shorter than the usual semester, and give you about an hour and a half from when you get it to when you have to submit it. That way I make it so you sort of have to write up notes for you, because if I give you that little time, even though it's in essence open notes, if you treat it like that where you look up everything, you wouldn't have time to finish it. So I want to put some kind of time limit on it to make you prepare, but I want to give you more time than usual, so if there are technical issues, they'll work out. So for the test, it'll probably be, let's say I do it regular class time, I make it available at 4:30, and then you have to upload it by, say, something like 6. All right, so any other, and I'll talk about that next week when we're getting closer. Yeah, so as usual, there'll be a review. Just a second. Sorry. Okay. Anything else? A revision sheet? I'm not sure what you mean by a revision sheet. Oh, a review. So review. So since the test is, sorry about that. Yeah. So since the test is Thursday, the class before Wednesday will just be looking at questions on the review. So I'll probably get the review out to you either at the end of this week or next Monday, depending on when I have time, because I'm giving a couple quizzes and I'm giving one test this week and one test next Monday. So depends on when I have time. But certainly Monday. So any other questions on that? Okay. So from the homework questions and from the stock handout, let me just look at a generic one. So number 2 says, suppose we have a stock that is currently at, and I'll write this down in a second, is currently at $50 and it's either going to go to $20 or $70. So we have, here's my shorthand, current price of the stock is 50. And in the future, it's either going to go to $20 or $70. And there's an option to buy the stock later for $60 and let P just arbitrarily be the probability that the price of the stock goes to $70. Then the arbitrage theorem says if there's a value of C and a value of P that will make the two expected equal to 0, then that's what we should charge for the stock. So we did one of these, I think, maybe 2, I forget. So what we want to do is get the expected value of the stock. And so just looking at the stock itself, and so we look at the 2 cases. So 70. So if the stock goes up to $70, then what's the value of, and when we say expected value of the stock, we're talking about the net amount we make. So if it goes to $70, how much did I make with the stock? And therefore, the first term is 20 times P. We assume we bought it for 50, we sell it for 70. And then if it goes down to 20, then how much did I make? Negative 30. And again, for the expected value, we multiply that by its probability. Then we do the same thing for options. It's the same questions. If the stock goes to $70, then how much did I make? $10, right? So sort of 10. Because if it goes up to 70, I'm going to use the option to buy it for 60, immediately sell it for $70 and make $10. But then remember, I am assuming, and I should have put this up above, that I had to pay C dollars per stock to have that option. On the other hand, if it goes down to $20, how much did I make? So I should only put up here C equals. Price of the option. So if it goes down to $20, how much did I make? Yeah, just the minus C. And now that we have the actual equations, let me say the arbitrage theorem again, which says that either there's a value of C and a value of P that will make both these equations equal to 0, or there's just always arbitrage. And so we solve this one, and we'll do one with more possibilities later, so you'll see it gets a bit more complicated. But this one's pretty easy because we have two equations with two unknowns, so it's pretty easy to see if there's a solution, especially because the top equation only has one variable. So if I bring the 30 to the other side, I get 50 times P is equal to 30. And therefore, P is equal to 3/5. And if I plug that into this equation, well, so first, this equation, you get the 10 minus CP minus C plus CP. So we just get a really simple one. C is equal to 10 times P. And solving for that, I get, obviously, 6. And so therefore, that's how much I should charge for my option. So at that price, there's not guaranteed arbitrage. Any other price, there is guaranteed arbitrage. So here's the basic idea behind the arbitrage theorem. So any questions on this? Okay. So let me do kind of an aside. Let me add in a B to remind you that there's sort of a second way we can solve this. So I just said that if C is any value except for 6, then there is an arbitrage situation, which means there's a number of stock and options you can buy or sell that is guaranteed to make money. So if I make C equals 1, which is not 6, obviously, then there should be such a bet. So I'll do that in the next one. And that will give us a different way of solving the first one. So again, any questions on this? So if I let X be the number of stocks I buy, so therefore if it's negative, that means I'm selling it. And same thing for the options. If Y is positive, I'm buying. If Y is negative, I'm selling, kind of arbitrarily. Then well, let me finish writing this and let me answer that. So, yeah. So, just so in some ways, C is right. So, in some ways, there's not really under and over. The idea is if C is either smaller or bigger than 6, then there's going to be a technique of that's guaranteed to make money. And I would guess if it's more than 6, you do it one way, and if it's less than 6, you would do it kind of an opposite way. But in both cases, you're, as in one, you might buy stock, and the other, you might sell stock. So these, pretty much the equations are going to be similar. Just realigned. So if the stock goes to $70, then what's the net amount I make from both of my bets? So buying stock and buying options. So again, for each stock, I make $20. So I make 20 times X. And for each option, I make, I forget, was it 10 minus C? Is that right? Yes. And then if it goes down to 20, I get that. So this is obviously in general, and then we'll put in C equals 1. So in this one, we could do this also. We could use this to solve for C, which is we could set both of these equal to more than 0 and figure out what value of C would make it so that there isn't a solution set. And as we did last week, we know that occurs when the two lines we get are the same line, so they have the same slope. So we would solve for Y in terms of X to figure out what the slope is, set the two slopes equal to each other, and solve for C. As I said, that one doesn't generalize as nicely, so we tend to use the other one. So if C equals 1, actually, I think the 50 is wrong. It was minus 30x, is that right? Because it was 50 and went down to 20. Sorry about that. That's supposed to be a 30. So give me a value of X and a value of Y that will make both of these positive. And you can see pretty obviously one's going to be positive and one's going to be negative. So give me a value of X and a value of Y that make both these positive. I think something like this works. So something like that works because if I put that into the top one, I get negative 200 plus 270, so I get $70. Put into the bottom one, I get 300 minus 30, so I get $270. Both of those are positive, so whatever happens, I make money. And if you think about it, kind of that natural next question doesn't really make sense, which is, well, what should I do to maximize my return? And the reason that doesn't in some sense make sense, which is if an x and y make both positive, if I multiply x and y by positive constants, it's still good. So if I want to make more money, instead of doing negative 10 and 30, I could do negative 10 million and positive 30 million, in which case I would make 70 million and 270 million. So I can continue along that line and make as much money as I want. So there are two ways. So for this one, if I asked like this, it would just be trial and error, see what works. If you want to be more complete, you can make them into inequalities. So take these two inequalities, make them both 0, graph the system of inequalities and find the region that has the solution set, and then you can just choose any number in the solution set. But we haven't really done a lot of systems in inequality, so I just ask you to do the trial and error. So any questions on this? So let me do another one. Let me do number 5. So a bit more variability. So now we have a stock that's currently at $100, and in the future it's either going to go to 50 or 175 or $200. So now we have more options. We could also start doing more bets, although since my background is in economics or finance, I'm not sure exactly how you do the other bets, but we could also do other bets. So to get the idea of just setting things up, let's again look at the expected values. So let's look at stock. So now we have the 3 options. So if it goes to $50 down to $50, then how much do I make? So this is kind of the more direct one. So if it goes down $50, then I lose or gain, depending on which way to do it. The 50, multiply that times the probability of it happening. If it goes to $175, I made $75 for each stock, multiply by its probability. And do the same thing for $200. Not quite as obvious. So if it goes down to $50, then how much did I make for the option? This one, if you haven't done the finance and or economics, I'm checking to see if you're okay with it. So if it goes down to $50, how much did you make? to the minus c, and then multiply by its probability. If it goes to $175, how much did you make? And the 25 minus c. Notice for the option, you don't really care what the initial price was. All you care about is how much can you buy it for using the option and the actual price. So the 25 is the 175 minus 50, 150. And then the same type of thing. Oops, I lost V2. The last one. We do know since these are the only three things that happened, that the sum of these three is 1. So I don't really need the P3. I could put 1 minus P1 minus P2. And again, the arbitrage theorem says either their values of C and P1 and P2 that make both these 0, or there's always arbitrage. So for people who've done linear algebra, why is this going to be kind of an annoying setup? So you'll notice, as I said, P3 is not really a variable. So we have three variables, C and P1 and P2, and we have two equations. So how many possible answers are there? And let me go back to the last one, which is it with two equations with two unknowns. There are three possible outcomes. One is there's one answer, which is what usually happens. One is that there's no answer, which is if they're the same equation, just multiplied. And in pretty much the same situation, there are an infinite number of possible solutions, which is that not only are they the same equation, but the inequality is on the same side. So here, what are the possibilities? How many possible outcomes are there? How many possible solutions? No? Right, so infinite is one possibility. The other possibility is that there are, so infinite is the more typical one. Sorry about my writing there. So 0 means that there's guaranteed arbitrage. And that would happen if one is a constant multiple of the other and they have inequalities going the opposite way. The infinite solution is kind of telling us that there's more than one possible value of C that works. So unlike the last case where we got, well, C is $6, here we would have a range with something like C works as long as C is anywhere from 5 to 12. And if we start adding one, so instead of 3, we had 4, then there would be 2 dimensions of possible outcomes. And so it would be even more fuzzy. Unless we added more types of bets. But since this is just kind of in the background, we don't really want to do too much more. So in some sense, for this one, this is what I want to do, just another one where we set up. So any questions on setup of these two equations? Yeah, as I said, I'm not really into the finance. So right, so here we can either buy or sell the stock and buy or sell an option to buy the stock. So if there's a third bet, and I'm not even sure, as I said, I'm not in finance things, so I'm not even sure what a third bet would be. But if there's a third bet, then that would give us another equation. So any questions on this? Remember, this really is just for the people who haven't done finance or economics, the intro into what we really want to do. which is what we really want to do, is let the stock price be continuous, where it can be anything, and it's changing as time goes along. So this is just to get some of the terms down. On the other hand, since we're doing it, I'll put it on the test, so something like the previous sum, number 2, could be on the test. I would not put something like 5 on the test. And for that more general one, we talked about Brownian motion. So remember, Brownian motion starts with the random walk, which is you're equally likely to go either left or right. And then you want to see what happens as the time between steps and the distance of the steps both go to 0. And as the limit of those both go to 0, we get this thing called Brownian motion. 1 dimension is kind of boring, but if you do it in 3 dimensions, again, that is pour cream into coffee. And the way it spreads is Brownian motion. And so we want that kind of randomization for stock. So stock is kind of randomly going up and down at some level. So we found a few things. First thing is, because we're looking at where we are at time t, it's the sum of a bunch of the random walk steps, which means it's normal. And we found that the expected value was 0, which we need because it's normal, so we need the mean and the standard deviation. And the variance is sigma squared times t. When we actually put this in terms of stocks, the sigma will take out, but for now we have the sigma squared t. Second thing we found, or I said, and I'm not sure why I'm using x. So if there's no overlap between the two waves, the first one is going from A to B, the second one's going from C to D. If there's no overlap, then those two differences are independent. The other one we did, which I did in a slightly different manner, is that if the difference in the length of the interval is the same, then the difference between the two is a constant distribution. And in particular, the interval from 0 to b minus a has the same length as a to b, so they have the same distribution, but b of 0 is just the point 0, so it falls off. So this we got to last Thursday, but what I want to do now, even though it's in some sense in the background, is let's actually do this. So let's go back this now, make this sort of a 3081 question, and just do some of the calculations about how Brownian motion moves. So any questions on this? As I said, it should be just a repeat of last Thursday. So Suppose B of t is Brownian motion with a variability of 3. Then what's the probability at time 5 we have moved to the right by 10 or more? And if you go back to 3081, we know no. Well, so the idea is here, unlike before, this is no longer discrete, so we're going to actually have to do the equation. So the idea is B of 5 is normal. So E of B of 5, like any of them, I won't write this for most of them because it's always 0. And according to what I wrote in the last one, the variance is 45. And so now the question is, B of 5 is normal. This is the 3081 question. So I have something that's normal with a mean of 0 and a variance of 45. What's the probability that that thing is more than 10? And if you remember from 3081, there are 2 ways, depending on who you had, 2 ways of doing this. The most basic way is you use the table. And if you use the table, and you switched it into z, which is, remember, the standard normal, which is the mean is 0 and the standard deviation is 1. And if we're doing that, then what did we do to 10? So how do we standardize a number? You subtract it by, right, so this, subtract the mean, divide by the standard deviation. Standard deviation is the square root of the variance. So we get that. And at this point, if you're using tables, you would look at a table, and depending on what table you had, you might have to subtract that from 1 or something like that. I'll double check, but I think I actually have a normal table on Blackboard. But the better thing for this setup is that we use a calculator for it. And if you're using a calculator, you don't really have to do this part, which is standardizing it, because you can just put it in as a regular normal. And for the TI 8384, what you do is kind of the same place where the binomial and the Poisson is. You do the second and variables to get to the distributions. The top one is normal PDF, which, to be honest, I don't know what you would use that for. So since it's continuous, it's just giving us the height of the distribution, which usually you wouldn't care about. So we do the normal CDF, the second one down. And depending on which version you have, either it's going to bring you back to the main screen, you have to fill in the numbers, or you'll have a pop-up, which is what mine does, and it asks for the left and the right. So here, the left is we want more than 10. And then really we want to go to infinity, but you can't put in infinity in a calculator, so just put in something big. So that's in place of infinity. If you want to make it obvious that it's going to be okay, you can do a 10 to the 99 or something like that. But that's certainly big enough. And then if you stopped here and pressed enter, it would assume it's a standard normal, but it's not, so you put in the mean and the standard deviation. And I get that. So with this by itself, it doesn't really mean anything because I don't tell you what this stands for or anything. But eventually we're going to want to be able to do this in terms of SOCs. So this would be the probability that the stock goes from $0 to $10 or something like that, which doesn't make sense. So with the extra words around it, this is something that you could have been asked in 3081. So any questions on this? Okay. Kind of a related thing, instead of asking what's the probability it's at a particular position, we could ask what's the probability it moves a certain amount. So what's the probability that from time 1 to time 5, it moves to the left at least 4 spaces, 4 units. And that's the third thing we had, which is that the only thing that matters is the difference. So this probably, so the difference is 4. And officially it's b of 4 minus b of 0, but b of 0 is a 0.0, so that drops off. And I get that. And so once I get that, you can say, well, that's really just the same as the last problem. There's just the initial thing. So finding the probability that changes something is pretty much the same problem as saying, what's the probability of being in a particular position for a Brownian motion. So this one, I don't have room here, so I'll do the next one. So any questions on this? Okay. Still B. So like the last one, we need to get the variance. And again, it's the sigma squared t. So it's again the 3 squared, but now t is 4. So now the variance is 36. And so again, I could do the standardization if I was going to use a state table. So do the -4 minus 0 over square root of 36, or I'll also go straight to it's just that now we want less than. So we want to go from negative infinity, so the negative 1,000 just to stand in for negative infinity, to -4. Again, the mean is 0. And 6. Not sure why. Didn't simplify that. Obviously, 30 squared is 36 is 6. And I get again a probability. So that's a probability it moves to the left at least 4 units over that time period. So let me do one more, kind of the most elaborate type of this, but it's not too much more. And I probably wouldn't do the whole thing. So let's find the probability of that. So you could have, but if I'm using the calculator, this part is saying we have a general normal with a mean of 0 and a standard deviation of 6. And so therefore I don't have to normalize it. If you're using the table, you will. So it depends on how you're doing it. So the most elaborate that uses pretty much all 3 parts. So I want to find the probability that from 1 to 3, it moves to the right by at least 4 units. And then from 16 to 17, it moves to the left at least 2 units. And so the second one says, since these two time periods don't overlap, 1 to 3 and 16 to 17, I split it up into two pieces because they'll be independent. So I can do the probability of the first multiplied by the probability of the second. And then the third one says, well, all that matters is the difference in time. So that first one becomes this, because b of 3 minus b of 1 becomes b of 2. And then from 16 to 17, the difference is 1, so it becomes the same as b of 1. And so that last line is the same as the line before it, using properties 2 and 3. And now for each of these, they're going to have different variances, so we're going to have to get the variance for each. So for this first one, the variance is the 3 squared times 2. And for the second one, the variance is the 3 squared times 1. Because our variance is the sigma squared times t. And put it into that. If you're using calculator, put that in. And again, the 1,000, the negative 1,000 are shorthand for infinity and negative infinity. So we can do them separately. So that's kind of the first part, which is we know it's normal with the given variance. And this, obviously, you should check. But when I did it, I got that. So any questions on this? So since I want to stop early, let me just introduce the next part, and we'll really do that on Wednesday. Do it on Wednesday. But any questions on this? Okay. So there are two things that incorporate Brownian motion into it. One is what's called Brownian motion with drift, which I'll talk about in a second. And in this case, and again, I'll talk about this in a second, we want to emphasize the variance. So for this case, the variance is t. So what I've done is I've just factored out the sigma, emphasize it. And then there is what is called geometric Brownian motion. And I said, well, we'll probably do this on Wednesday. And this is what we really want. So this is something that is growing exponentially, but with some randomness involved. So this is eventually what we're going to do for stock. And in this context, the sigma is the volatility of the stock, which is why we want to pull it out, because that's something we can measure by following the stock for a while. And mu is the drift, and that represents a few things thrown together. One is there's inflation, so the stock is tending to go up in price because everything is tending to get more expensive. And also, it comes from the fact that in general, the stock market has tended to grow a little bit faster than the general economy. So therefore, our stock will grow a little bit faster than the general economy, and if we take a generic stock. So the mu is kind of a combination of the fact that the stock grows faster and also inflation. So going back to this one, it's saying it isn't just randomly going up and down, it's increasing on average and randomly around that increasing value. So this is what we're going to use for the next part, where Brownian motion is part of it. And the first step that we're going to talk about is just, well, before we actually talk about what the price of an option is just, if this is our model, then what's the probability the stock grows from $50 to $70 in a year? And also in the background, why is it okay to use this? So what are our assumptions so that this is the model that works? So this is the quick intro into where we're going. The last thing with this is, as I said, find the price of an option, which officially is Black-Scholes equation if you've done that. All right, so any questions on where we're going? So as I said, in case there are any really last minute questions about the take-home, let me stop recording here. And if you're okay with this and you are done, don't have any questions on the take-home, we're done. Otherwise, stick around and I'll go over questions on the take-home.